Hello guys, welcome to our new perforator club. So, can you please write in chat? Do you hear me? Do you see me? Is there any issues? Hello guys, we're good. Welcome to our new perforator club. So, can you please write in chat? Do you hear me? Do you see me? Is there any issues? Hello guys, we're good. Welcome to our new perforator club. So, uh, yeah, so I've heard some echo in mind. So let me know if it's fine now. And by the way, are you able to write? Yeah, okay. So you are able to write in chat. So as usual, that's our typical. Oh, okay, two of me, and now I believe I had the YouTube stream opened, and the OBS was also capturing my system sound. Is it fine now? Okay, perfect. So um, today is a really interesting topic. And generally, it's our regular perforator club. So feel free to ask questions in chat. So I'll try to answer them at the end or like in progress when I will see them. Um, we're gonna talk about the JMeter, especially the parallel controller. So it's pretty interesting topic because um, many people, like in many projects, they actually interact with parallel controller. They need to use it in their scenarios to kind of trying to emulate realistic scenarios and so on. And like I have faced with like multiple challenges or kind of issues when working with parallel controller. And unfortunately, mm, most of them they were not pretty easy to fix. Unfortunately for us, so I had this plan to like figure out what are the workaround or like how to fix the problem so we can create more like high quality scenarios. So that's what we are gonna talk today. So yeah, we'll start with some basic stuff like why do we need parallel controller, what are the use cases, but in general like through the event we'll go into challenges, especially into workaround and fixes, and I'll share with you the working solutions for that. So that's yeah, that's me. So I believe most of you know who I am, and like also you have joined like our perforator club. But if not, feel free to like subscribe to our channel and the perforator club in Telegram. So it's a performance related community. We share the experience, ask some questions, reply to questions, and share some interesting insights. And also we have uh, regular events related to performance testing, like today's one. So feel free to join there. And today's agenda generally is, first of all, understand what is parallel controller, why do we need it, and how people are typically using it, and why they might be wrong. And we'll go through like three challenges you may or may not like faced in past. So it might be, it should be useful for you, even like if you have not used parallel controller at all. uh, you cannot guarantee, like I cannot guarantee that you will not get new project where you will need to use it. So let me move my picture a little so you can see more text. All or anyway, let it be because I will be too small. Yeah, so the challenges we're gonna talk today, first of all, when you're running the parallel, generally you see everything here. So it's more like an agenda, just for you to understand what will be here. So at the beginning, like first part of this presentation, it will be focused on like everybody, like technical and non-technical guys who like have a lot of experience or not. Um, Second part will be like actual the step by step debugging and trying to fix performance issues in the parallel controller. So it might be like quite hard maybe for everybody to understand what's going on there, but still I want to share this information even for myself in future because um, yeah, like, any information is can be easily erased by your from your memory. So I want to like leave this track somewhere, and like uh, probably in this event is the best place to leave it. So yeah, let's start. So what is the parallel controller and why do we need it? So in typical modern applications, uh, we are trying to make them as fast as possible. And one of the approaches is to, let's say we have a browser, we have an application in browser. And one of the approaches is to send requests to backend in parallel, not sequentially as it was like 10 years ago, but up to 6 parallel requests. Right now, where browser allows you to send. So on this screen, let me find. Sorry. Yeah. So on this picture, you may see that a bunch of requests, they were executed sequentially. So we got one call, then I got another call, and at some moment, some requests they are executed in parallel. Usually, it's the API call, like API request to backend, where we're just trying to get some data, to for client side JavaScript to interact with, and in this case, we got like 3 parallel requests, and then later we got how many? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 parallel requests. The problem you may face when you're trying to cover or test these types of application, and honestly, right now it's like most of them they are using parallel requests. That when you load page in browser, page load time it's like 2.7 seconds. It's here below. It's probably it doesn't fit in the viewport, but still, trust me, it was 2.7 seconds. Here you can see the timeline. But when you record specifically the same exact page, just like as usual, create a test script recorder, set up the proxy, and record all the requests except static resources, static content. You record it in JMeter and run the test. You may see that test execution, like this user action execution, it took 7 seconds. So it's like more than 2 times slower. And the more requests you are executing on the page, the bigger it will be, like the bigger difference you'll get. And that's the main kind of uh, reason why people start using parallel controllers. Because parallel controller, its goal is kind of like your idea is trying to eliminate this difference. In browser, we have 2.7, in JMeter, we have 7 seconds. Uh, if we have such kind of difference, probably your product owner or your team will kind of will be a little bit confused and may stop trusting JMeter results. Because like, why in your test it is showing us that the checkout of order it takes 20 seconds. In reality, it takes 5 seconds, and it will be really hard for you to prove them that your testing approach is legit, and that's fine, right? So by default in JMeter, all requests, they are executed sequentially. So there is no way out of the box how to execute requests in parallel. So everything that you have in your under your thread group is executed one by one. But we can, just to prove this theory, it's a common fact, honestly, but we can also check it. So I want you to show not only things related to, like, issues related to parallel controller, but also kind of approaches how you can validate your scenario, your script, your testing approach, and is there any issues or not. So it is pretty typical approach of using proxy debugging tools. For example, like Charles Proxy, Fiddler, Proxyman, whatever. So their goal is to uh, kind of capture all the incoming traffic. So our goal from JMeter right now to verify, like, do we have requests sequential or in parallel? Our goal is to send all traffic from JMeter through, in my case, it's Charles Proxy. So the easiest way, like, there are multiple ways, so we can start JMeter with specific proxy settings, but in my case, the easiest way is just to set up HTTP request defaults and set like localhost and 888 port. It's the default port for proxy debugging tools. And also I have Charles Proxy opened, so all traffic from JMeter, instead of going directly to server, will go through Charles Proxy. So we start the test, and what do we see? Yeah, that all requests are executed sequential. So we got one call, second call, and then like waterfall of request execution. So kind of we just proved that it works like this out of the box. So to be able to execute the request in parallel, we need to install Parallel Controller. As usual, you go to um, plugin manager and find the Parallel Controller, install it. That's fairly easy. So you install it, and what do we see? It's like BZM Parallel Controller. You add it and add all like necessary requests which you want to execute in parallel into your thread group, and like you add the Parallel Controller into thread group and all requests inside the Parallel Controller. And the good thing, like from the first side, that Parallel Controller, it has this limit max thread number checkbox. By default, it is selected, and we also have max threads limited by 6 by default. So it might give you at least hope or like idea that probably Parallel Controller should work like a browser, right? Why you may think this? Because again, another common fact that browser is limited, like browser is limiting you by opening up to 6 connections per host. So in our case, browser will be able to open like up to 6 connections per our API host and our web, like API server and web server, because they are on the different hosts. But unfortunately, it is not working like this. So from the functional perspective, yeah, we start the test, like it's parallel controller. We run the same amount of requests, and test is now this iteration. It is executed in 3 seconds. Yeah, like yo, it's big win. Yeah, because we have 3 seconds instead of 7 seconds, and 3 seconds it was similar to 2.7 seconds we got in browser. At least like the difference is now it is not so significant, right? And like just to like another note, in this case, we added all the requests inside the parallel controller just to simplify the example. But in reality, we need to like analyze how browser interacts with your backend, because usually some requests, they are executed. Let's say you have first 4 requests executed sequentially one by one, and then you have 2 batches, like one group of parallel requests, then few more sequential calls, and then again one more batch with parallel execution. So all sequential calls, they need to be placed like outside. So in my case, like I need to analyze the waterfall, how the page is loaded, and try to create like the corresponding structure, at least similar. No need to uh, try to mimic like 100% same behavior, because sometimes, even like in this case, we got like it looks like they are sequential, right? This first and second, but in reality they are parallel. But this third call, it started in the middle of first one. So unfortunately, like it will be pretty hard to emulate this kind of behavior. So in my case, if I see that something is like this call, it starts like more than a half of first request, then I'll make them sequential. Usually it works fine. So as a result, I ended up, so it's like I haven't spent too much time like polishing this example, but just for you to understand. So we may have, let's say we have this open event page. So in this case, we have 4 requests sequential, then we have one parallel controller with 4 requests. So it means that they will be executed in parallel. And only after these 4 requests will be executed, the next parallel controller kicks in. And here we have like how many? 20 requests. So these 20 requests will be executed like maximum 6 at a time, not more. And yeah, so that's how it works. Usually you may have like one parallel controller or multiple. It doesn't matter much. And generally speaking, so most of people I have seen which worked like which have used parallel controllers in their scenarios, uh, so they end up at this moment. Like they created, they see that a bunch of requests, or they see that our user action takes too much time comparing to real behavior. So let's put some requests in the parallel controllers. They put them there, and that's it. So they are ready to run tests. But as usual, you need to, yeah, JMeter is good, but plugins, you obviously need to verify and validate and kind of try to confirm that everything works as expected, because it's open source. So it was developed by somebody, and maybe they have not tried to implement what you need, like this realistic behavior, maybe. So let's talk about challenges. So this part we talked about, it was pretty obvious that I believe everybody are familiar with the parallel controller. On challenges which you may or may not notice before. So first one, uh, right now, like first one, it's called like display transaction controller and separate request data for comprehensive results analysis. So usually when you're analyzing your test results, they just your test executions, you need like to get really deep understanding of what's going on. You need to have both user actions and separate requests metrics. So what is user action? Let's say we are creating we are covering end-to-end flow, like open the home page. We have some events application. So we have like buy a ticket, we have open homepage, open event page, add some comment, check some, I don't know, other pages, and so on. So it is user actions. Each user action or transaction, it includes many requests. So in the previous example, it was open event page, and it had like around how many, like 20 or 30 requests, right? So I want to understand like the total number, how long it took to load this page, and also I want to understand how long this API 3 envelope took, or events tickets took, and so on. And here is the first challenge, because like right now we were, if I run the test, like the same version of test, I am getting only separate endpoints response, like response times, like just different metrics, throughput, errors, response times, number of samples, and so on. But probably my team and I personally, I would also be interested in the total response time, like how long it takes for the whole page to load, why it is needed. Because generally, even if I have all the separate endpoints, because many of them, in our case, they are executed in parallel, it's pretty hard to calculate what is the mm, total time. Because if you sum up everything, like all the like median response times, it will be much bigger number, not like 7 seconds. So in this case, it's 7 seconds for the whole test, and it was 3 iterations. But yeah, so as I said, we're interested in both thing. So usually, typically, when we are not using parallel controllers, the typical approach is to use the transaction controller. So transaction controller is the element to um, which allows us to get aggregated information for all the requests inside the parallel transaction controller. So usually you just name it like open event page, you put all the corresponding requests inside it, and then what it does. So if you are not checking this generate parent sample, not selecting this checkbox, it should provide you two things. First one is separate requests metrics, and also generate a parent transaction called open event page with like total processing time of all its child elements, all child requests. And yeah, in reality, it works. So it is showing all separate requests and parent sample, parent transaction. But the problem is that it is not including and it is not considering that some of these requests are executed in parallel. So when I executed this scenario in one iteration, it took 4 seconds. But open event page, transaction controller, it reported 10.2 seconds. So it is kind of problem because we are not getting relevant numbers, right? So we are generally, yeah, we are sending requests in parallel, but the numbers, they like seems like we are not using parallel controller. So we are kind of getting back to the beginning. We are not achieving our goal. So, and that's a problem, kind of. So I want to see 4 seconds in open event page. And parallel controller itself, it has the generate parent sample checkbox. So you can go inside it and check it. Like some of you may use it also, but unfortunately, it is not solving the problem too. Because when we select generate parent sample, yes, we start getting like the parallel controller just one record with total duration of all the parallel requests, like considering that they are executed in parallel. So it is smaller numbers. But we are losing all that parallel requests, separate requests. So we are not getting that data at all. So it's a big problem. So in my case, I would prefer not to choose generate parent here because we're just losing a lot of really useful information. And unfortunately, there is no way to kind of find a workaround. So usually, if something is not working in JMeter, you can kind of work around or hack it. Like sometimes simple, sometimes not. Sometimes not. So here there is no simple workaround, unfortunately. So I had this problem on on few of my projects, and I never had time to kind of invest some time into it. But like now I got like the big project with a lot of like where parallel controllers, they are really mandatory. So like even if it's not my like nobody asked me to do this, and like I did it actually in my like mostly in my free time on the weekends and so on, but I needed to define some approach how I need to work around this challenge because Otherwise, I'll get not relevant results. But in this project, it is not. It is pretty critical because some user actions, they like have 50 requests, and most of them are in parallel. So without parallel controllers, we will have like 20, 30 seconds of response time. But in reality, it's like 5. Yeah, so like I checked really, like I will not go through all the like approaches I have tried because it will take a long time. So I'll end up with the final solution which I'm using right now. So like I have done some experience with different implementations, but like in all cases, my goal, like each had its own pros and cons, but in my case, the main goals was like two goals. First of all, like I didn't want to modify like any like JMeter code, kind of source code, core or plugins itself, because like it will make it harder for like our like other teams to use, or like for everybody else to use it, because you will need to change the kind of plugins and jar files itself. And also, I want to keep the overhead like as small as possible. So, what does it mean? So, when you create, when I create a script, I don't want to spend much more time on script creation and maintenance. So, it should be as simple and as straightforward as possible. Yeah, the actual implementation might be hard, and you will see, but the task creation should be simple, and like there should be no big chance to make a human mistake because you forgot to copy paste something or change some parameter and so on. And also I want to keep resource utilization as small, like as low as possible. um, so that's how the final solution looks like. So we'll go deeper a little bit on the next slide, but in general, um, like here, I have added several components which are required to like to use this kind of approach or workaround. But as a result, what we're getting separate response times for separate requests. And also we got open event page, which takes like 4.5 seconds. And yeah, the whole test, it was only one iteration. So in this case, it took like 4.5 seconds, and the duration of test was also like around 4 seconds. So we are pretty good. So what do you need? Like if you want to use this on your project, what you need to do? Uh, mm, Multiple things. So it is not, single line or single element change. Yeah, in this case, hold on, let me move because you do not see a code. Let me move myself down a little bit. Yeah, so first of all, like the general idea, how do we measure, like, and I ended up with this approach because it seemed to me as the best one. I tried different ones too, but that's the best one, for my opinion. So we got, as usual, we got some parent controller. So in our case, let's say it is transaction controller or simple controller, doesn't matter. So we got this controller, and we got just to group all the requests for user action. And also we have something inside it. The main idea is to actually get two timestamps. First one is before all the requests, like when the user action starts to be executed, and second one at the end, when the user action is fully executed. So we have these two elements, like called, like in this case, technical calculate transaction processing time. So and this calculate processing time, it actually gets two timestamps. So it is uh, having the same code. So for both before and after, it is exactly the same implementation of GSR 223 sampler. So in like previous versions, I had like um, kind of get a start timestamp, then get end timestamp. So it was like two separate elements. So it was a pretty big mess, and like it was not easy to maintain and create scripts. So right now we have the test fragment with the implementation. Yeah, so implementation, it looks like this. So like the main goal, the main idea of it is to get the timestamp before all the requests, then get timestamp after all the requests and calculate the difference between them, and then generate a sample result with the name of current controller, like open event page, with the duration, like how long it took, and also set is it successful or not, and send this sample result to listener. So like under the hood, yeah, for those people who are not familiar with like JMeter API, you may like ask like, what is going on? I don't understand anything. So generally, goal here is just to calculate the duration of this user action and create a result for listeners, because we are analyzing results from listeners. It doesn't matter, is it aggregate report, or is it util3, or is it backend listener to send data to InfluxDB or whatever. So it will share this newly created transaction to listeners. So first, like good point is that all logic is actually kind of placed in single controller. So when you create your script, uh, why it's in test fragment? Because it is only one place where we keep the code. And then we create the module controller. Let me show. Yeah, so module controller. And we refer to this JSR223. And then after you created only this one module controller, you just duplicate it. Your goal is actually just to put two module controllers in your user action. That's it. So no extra efforts needed from your kind of perspective when you're creating a script. Another point is that you need to you need to use simple controllers instead of transaction controllers. Why? Because if you have a transaction controller, in addition to getting this open event page, like one sample, which is generated by like this code that I showed you, transaction controller will separately create one more transaction controller parent sample, but the number will be wrong. So in my case, if I would use not simple controller here, but transaction controller, I'll get two samples. One is 4.5 seconds, second one is like 10.5 seconds. So it is like breaking our statistics. So what do you need to consider that if you're using at least one parallel controller for your user action, you need to use simple controllers. For other actions without parallel controllers, keep using transaction controllers. So in my case, in my scripts, I use both transaction controllers when I am not using parallel controllers, and simple controllers when I am using them. Do not use, as I said before, do not use generate parent sample in parallel controllers. We need to keep metrics raw. All the aggregation stuff, like total duration, will be calculated by this code. So like generally, we can, like, if somebody is interested, we can get back to the actual code, like go through it line by line, what it's doing. If somebody is interested, so just let me know at the end when we'll have the Q&A session. But just it works. And also, except this code, we also need to get separate assertion, because like let's say, how transaction controller works. Transaction controller is failing when, like, if at least one request is failed inside it. So we need to like have the same behavior for this parallel request too. So I needed to create a separate assertion, which should be placed on test plan level, which actually checks all the parallel requests execution and their response statuses. and mark transaction as failed or not. Again, you don't no need to kind of maintain anything there. You just add this assertion with few lines of code, and it should work. This exact solution um, should work in your case. If you have this kind of type of end-to-end scenarios, it should work without any extra modifications. So bolt on, we can call it. So just few examples of what I already talked. We're using simple controller instead of transaction controller if we have the parallel controller inside. Then we use module controllers at the beginning of user action and at the end. Both module controllers are exactly the same thing, referring to test fragment, like GSR 2.3 implementation in test fragment. And that is assertion implementation. Just a few lines of code. General idea is to check and mark transaction controller this aggregated sample result for user action. Is it failed or not? That's it. So for challenge 1, it is pretty straightforward and, at least I hope, easy to understand. Maybe even if you don't understand the code, because we have not spent too much time, because I don't see actually a reason to spend too much time digging deep into what is going on here, because it doesn't matter, because it just works. That's it. So most of people should be kind of happy with this implementation. So challenge 1 is done. So we are getting both generated transaction and separate request. Yay, cool. But we start running tests. And you may notice, if you are, what do you call it? You have this attention to details, and you analyze your test results precisely, then you may notice that when you run tests with parallel controller, your separate requests response times, they are higher than comparing to test without parallel controllers. So that's example of pretty simple flow. So we got two thread groups. First one is without parallel controller, some amount of request, and second one is exactly the same, but we just add the parallel controller. That's it. And now it's only one thread and 5 iterations. So, and if we compare the test results, you may see significant difference between them. So second run is with parallel controller, first one without parallel controller. So difference for, let's say, median, 500 millisecond difference. It's huge. It's exactly the same request. So in general, test execution, kind of user action, processing time, or task duration, it will be faster because we are using parallel controllers. But there is something wrong with the separate requests, because we see this clear degradation here. And the problem, if you dive a little bit deeper inside it, the problem is that generally seems like that every request inside parallel controller, it is establishing new connection. So if you go through all these requests which are placed in the parallel controller, you will notice the connect time, which takes some time. Yeah, in this case, it's less than 200 milliseconds, but sometimes it is higher. So why? And that's kind of another huge challenge. So we are establishing new connections. And because of that, it's I have challenge 2, and I have two kind of sub challenges here. So first one, that we are just getting it's at the end result, right? So we are getting longer response times. But another more more global and more fundamental issue, that JMeter is not the JMeter, the parallel controller is excessively using resources. So it is generating the kind of extra workload on the load generator to use. It is establishing, honestly, it is establishing um, extra unnecessary threads, connections, using more RAM, and because of that, because of doing all that previous stuff, it is using also more CPU, like process CPU, and also spending more time for garbage collection because we're using more memory without like any reason for that. So that's another big issue, which we are trying to face and fix. So that's example. Again, we get back to our Charles proxy. So I just executed just 20 requests in parallel controller. So out of 20 requests, you can see that there was 20 connects and 20 SSL handshakes. So we created, instead of have it, so in this case it was only one thread. So if we like make a small step back and try to kind of understand, like, or just recall how the browser works. So browser is limiting your application to open maximum 6 connections in parallel, right? In this case, we had one user, like one JMeter thread, which opened 20 connections. And like, actually, it depends on how many requests you have in parallel controller. If I'll put 100 requests in parallel controller for one user action, it will create 100 connections. So it is generating significant overhead on your application under test, like your end application you are testing. Because normally, application will not spend these extra resources for establishing so many new connections. So in my case, I had how many like, I believe more than 100 parallel controllers in my script because it's a huge scenario. And generally we created like I checked, so it was creating more than how many 20,000 of connections just for, so it create one user, one thread, for one iteration of your scenario, it created 210 connections. So you just need to multiply it by amount of users you want to generate. So if it is like 100 users, multiply 200 by 100 users. So it's a huge numbers. And generally your test results, so you are exhausting your law generator, but that's not the main problem because, yeah, I may run distributed test. Okay, you may create multiple law generators, but you are generating unrealistic load and huge overhead on your end application. And that's the main fundamental issue with kind of original implementation of parallel controller. So when I first faced this, like, I just wanted to understand, like, is it problem with parallel controller or the regular JMeter also works like this? But yeah, answer is that problem is in parallel controller. So when we run requests just sequentially without parallel controller, only 2 SSL handshakes are done, like only 2 connections are established. All other requests, they are keep alive or they are reused. You may ask, why do we have 2 connections, not 1? Because normally JMeter should create 1 connection per thread. But in our case, our scenario, it has like one API. We have 2 hosts. We have 2 servers actually. One is our web server and also API server. So we need to establish 2 connections to both of these servers. That's why we have 2. But in general, without parallel controller, JMeter works kind of as expected, without any issues. So why it is working like this? If you dive a little bit deeper, if you go to some JMeter, like this, JMeter has this Google Groups forum, And also, like parallel controller, they also have their own like Git repository where some issues were reported a long time ago. So if you dive a little bit deeper into the topic, you will see the comments from the main contributors for this parallel controller contributors, that it wasn't designed to act like a browser. Like despite having all this like limit max thread per like limit max thread number, which is equal to 6, so it just pushes you to think that it works like a browser. In reality, it is not designed to work like this, just by design. So the main idea is of parallel controller, and like I do not have this kind of quote of this message, but I saw it somewhere on that forums when I was trying to find what is the like, maybe there is a solution, maybe there is a kind of workaround we can do, and so on. So like one of the main contributors, like pretty good guy actually, so he mentioned that it is designed pretty straightforward. So there is no any complex logic inside the parallel controller. Its goal is to create separate thread for each child element inside it and execute it. That's it. So like execute in parallel, right? So if we have 20 requests inside the parallel controller, so that's just an example. Yeah, here. So we have like some amount of requests here. How parallel controller will act? By design, it will create a separate thread, Java thread, uh, for each child element. So it will create how many? One, two, like 25, let's say 25 new threads, and each thread will execute this child. Like one kind of step forward. So generally, parallel controller creates instance of JMeter thread and just reuse common JMeter thread implementation, because in JMeter core there is an implementation how JMeter thread need to interact with different elements, how it need to like execute samples, controllers, post processors, listeners, and so on. So parallel controller is just reusing this logic, so they are not adding too much from themselves at all. And that's a problem because we are creating separate thread. Separate threads, they have their own context. And new thread has new connections. Because it's the default JMeter behavior when the like if we forget if we forget about parallel controller, just consider the normal thread group and normal threads. So yeah, each new thread, it is creating new connection, because in from JMeter perspective, each new thread is a separate user, so it's a separate client. We need to establish new connection, right? But the parallel controller, it should be a little bit different, right? So we need to reuse the connections. So we have one JMeter thread which execute the whole scenario, and we also have these smaller JMeter threads, like parallel controller threads. They're called parallel JMeter threads. Yeah. So they need to be, like my understanding, they need to be reused for one user as it works in browser. So because of current implementation, because connections are not reused, we are actually generating this unrealistic overhead on like our load generator and the server side, which we are testing. So yeah, like first of all, I like on all my like courses or trainings or speeches, presentation, whatever, I always repeat that if you have some problem or you want to do something in JMeter, first of all, before writing any code, try to kind of find a solution or work around with existing components. And that's what I try to do first of all. So our like main idea here is, considering all the previous information I told to you, that parallel controller is actually creating separate thread for each direct child. So we can try to reduce amount of threads created. So instead of having like 25 requests here, instead of having 25 new threads created, we can try to uh, work around it a little bit. So I like parallel controller itself, it doesn't care what to execute. So it will execute any child element. So it may be the sampler, controller, post-processor, listener, whatever. So this small kind of workaround, in my case, I was trying to add 6 simple controllers inside the parallel controller. So this thread 1, thread 2, thread 3 is the simple controllers. And just distribute all 25 or like whatever amount of requests between these 3 simple controllers. What it gives us. So like I put first one into first thread group, first thread, first simple controller, second one into second, third into third, and like the seventh into first. Why I do this? Because generally these simple controllers, all these 6 simple controllers, they will be like 6 parallel threads, and they will be executed in parallel. But inside simple controller, for example here, they requests will be executed sequential, one by one. So just to emulate the waterfall, kind of the sequence of requests, I am I'm just putting them in this order. So first one goes to first thread group, second to second, and so on. Just to have first request from first request from second, and first from third executed in parallel like it works in browser. So it helps us a little bit. So if we run the kind of test, so we created how many? Like 7 connections. So that's not bad, because instead of 20, we created only 7. 7 because we have again we have two hosts, one request for a web server and application actually API. But the problem will be that unfortunately it helps us only on one iteration, or like on the level of one parallel controller. Because if we have multiple parallel controllers, or even when we run the test with one parallel controller but for multiple iterations, when every time when parallel controller will be created or will be executed, it will create again 7 connections. So it is not kind of, it reduced amount of connections and threads used for like in terms of one parallel controller, but usually you have many of them, so it's still spending some time. Like, yeah, it spends less resources on connection establishment, but it is not kind of the solution, like the best solution. It helps only partially, and I am not happy with this solution. So kind of we cannot reach any acceptable solution which solves our issue. So we need to kind of, and also I spend a lot of time trying to find any, like, because I was wondering why nobody raised, like, yeah, why nobody fixed these issues yet. Maybe because the parallel controller, it is not kind of in active development, so it was created some time ago, long time ago, honestly, and like last several years, it is not kind of actively maintained, because maybe like so it is developed by JMeter, so maybe they have another priorities or what. So like they have a bunch of pull requests not related to this actual problem, but like they are still in progress. They are still open, this pull request, even that the solutions or like fixes there, they are pretty simple. Or maybe another problem is that the actual, like, to fix this challenge, like challenge number 2, you need to actually redesign the parallel controller architecture and create it from scratch. And maybe like they don't want to do this because like nobody asks it, for example. So after not having any useful outcomes from forums, Stack Overflow, and so on, I decided to go into details. Like generally how it looks like, you got a source code of JMeter, you got a source code of parallel controller, you like make a remote debug session to run in JMeter, and you start debugging and profiling. Like for debugging, I used like IntelliJ IDEA, like it's an IDE for Java, and for profiling, it's a JProfiler. So we will go step by step what I was trying to do and like what was the end result. But like probably some of you may like may not be too interested into those details. Yeah, just because not everybody understands the how JMeter works under the hood, or like they're not too familiar with the code, and probably they just came for the solution, right? So let's first of all, let's check what is the kind of end result. So what we are able to achieve, and like how we can use this improved parallel controller. And then after that, we can go through all the details, like what was changed and why, and like what maybe things were checked. Because like this step-by-step approach, how it was fixed, like why I also want to share it instead of just sharing the solution and like test results, because it also might help somebody to figure out what is the approach to kind of localize. So it is actual performance issue, but usually when we are running performance tests, we are finding performance issues in the end application, right? So and we create some issue to developer, and he's like figuring out what is going on. In our case, it's the problem in our testing approach. So probably developer will not help you. You need to figure out what's going on there. So like my goal is to show like what was like my path, and just an example for you also how you can do similar things on in your future challenges with JMeter or anything else. So the test results. Let me again move myself. So we need to have this table. So in this example of test, I have executed a lot of tasks, like single user, multiple users, different kind of scenario structure, like with few parallel controller and few requests inside them, with many parallel controllers and like hundreds of requests inside it. So I'm not going to share all the results, but in general idea, just to understand how bad it was initially. So scenario is pretty straightforward. So we have 10 JMeter threads. We have 30 parallel controllers. Each parallel controller has 10 samplers. It's just an HTTP request. And 5-second sync time between parallel controllers. So it's like send 10 requests in parallel, wait 5 seconds. Send 10 requests in parallel, wait 5 seconds. And it was executed for 6 minutes. Why 6 minutes? I don't know. Just because I decided to run it for 6 minutes. So that's the metrics I got. So after this test, or during this test, we had 1,800 Java threads created in original one. In improved one, it's only 76. Each Java thread, like they are kept alive, so they are like even if thread is not doing, it is still like holding some resources, especially RAM. Yeah, not much, but still it is using those resources. Also, the biggest part and the biggest challenge we wanted to address is the establishing HTTP. In this case, it's HTTPS, but it doesn't matter. So established connections. During these 6 minutes, 10 users established 22.5 thousand of connections. That's hell much, because probably your server might get this amount of connections during a day, not during like 6 minutes time span. So here is the significant difference, and like huge problem with like if you're running the parallel controller, if you're using parallel controllers in your task, probably your task and your testing approach and your testing result, they are wrong. So use optimized one. So as for other metrics, yeah, we also like these first two is the highest improvement, like the biggest improvement. We also reduced a little bit, not a little bit. So the RAM usage, it totally depends on the scenario complexity. So it still has a pretty decent improvement in terms of memory usage, and also how much CPU do we spend for garbage collection to free up this memory. We also a little bit decreased the CPU usage, and the throughput was also a little bit increased, but throughput, it also depends on your scenario. So in my production scenarios I'm running, throughput is significantly increased because of it, because I am using a lot of threads, and initially, because of using too much RAM, JMeter was just struggling to operate at all. So pretty good improvement, right? So let's check how to install it. So I placed like there are two jar files which are changed. So we got the actual parallel controller, like JMeter Parallel. So go to this Google Drive. I'll share like, don't try to download it right now. Oh, I'll add this link. So I'll share this presentation first of all. I'll share this presentation in Perforator Club. So feel free to join and check it out. And also I'll share this archive too. And the links also will be in description for this video, especially for this Google Drive link with archive. So this archive, it has two jar files. First one, it's the modified JMeter core. Yeah, unfortunately, we needed to make a tiny change in JMeter core. Why? Because generally, as I said before, parallel controller is heavily dependent on core JMeter implementation. So they are reusing like almost all stuff related to the actual sample execution, connection management, and so on. So we needed to add some small tiny modification. It will not affect anything else except parallel controller. If you're interested what and why, it will be a little bit deeper in this presentation. And the actual parallel controller. So you will have to modify like fixed versions in this archive. So your goal is to get into your JMeter installation directory, go to libx, and remove Apache JMeter core jar and JMeter parallel. Like now it's 0.11, but I am not pretty sure that like I'm pretty sure that it will not be updated too soon. So you will have 0.11, or it might be like 0.12, 13, whatever. Replace this parallel controller jar and place two jar files here and restart JMeter. That's it. That's what you need. So one note, parallel controller itself, it should be more version agnostic. So it may work like with JMeter 5.5, with JMeter 5.4, and so on. But the core itself, so it's a JMeter, it's actual JMeter binary. So the JMeter core, fixed JMeter core, is built for JMeter 5.5. So probably it will not work with the newer versions like 5.6 or like 5.7 when it will appear. So if you want, my suggestion is just like to use 5.5 JMeter and like just enjoy your life. If for some reason you like specifically want to use the newer version like 5.6, 5.6.3 or whatever, you will need to modify, like add this small like 2-line change in the JMeter core. I'll show you later at the end how to build the actual plugin and the JMeter core from the source. But one like disclaimer here. So if you're trying to use it on your version, something may break. Like I don't I mean that the parallel controller itself might not work with the newer version. Let's say I have seen some pull requests in like in their repository, so that parallel controller is not working in JMeter 5.6, just because in JMeter 5.6 there were some incompatible changes with current parallel controller implementation. Just because parallel controller is heavily dependent on the actual classes and methods implementation from JMeter core. So if JMeter devs they change something significantly in the core, something may break in parallel controller. So if you are like pretty enthusiastic and you have time and desire, yeah, you can update it to 5.6, 5.7, any newer or later, older version of JMeter, but you will need to spend some time testing it and validating that it is working properly. But in general, these two jars, they have only 4 changes, like final version. It has only 4 changes, and we will talk about them later too. But for the like common user, if you are not interested what was exactly changed, just use these jar files and you are good to go. So they are called like JMeter Core with Parallel Controller Performance Fix and JMeter Parallel 012 with Performance Fix. You need to remove original core and parallel controller jars and put this one here. Restart JMeter and let's see how it works. So we have again parallel controller, 25 or some requests inside it, and we have 1 thread and 3 iterations. So it's more like just a demo of from functional perspective how it works. So we have 20 requests inside it probably. So instead of having 60 connections, now we have only 7. And 53 requests, they were kept alive. But at the same time, requests, they are executed in parallel. So the most, what do you call it? People who are paying attention, I don't know what do you call it in English. You may notice that why do we send only 5 parallel requests, not 6? And the answer is pretty simple. So I have selected here only like our web server and API server calls. But in the scenario, we also have like this like envelope centric key. We also have some requests to the Google. So they are just like I was not including them. It was just easier for me not to include them in the Charles waterfall, right? So trust me, they are like sending 6 requests in parallel. Let's get back a little bit. Yeah, I dropped that slide. So let's get back to the table, and also somebody may notice and ask a question. Yeah, we have a significant improvement in established HTTP connections. So instead of 22,000, we created only 371. But why have we created 371 connections during 6 minutes test? So we had so the main goal of these changes is to make parallel controller as close to browser behavior as possible. So we have JMeter thread, and I want JMeter thread is using some parallel controllers inside it in scenario. So I want this parallel controller to create 6 extra threads, 6 connections once, and keep them and share them between all the parallel controllers in scope of JMeter thread, in scope of one user. So kind of one user starts interacting with the page and opens 6 connections and keep them alive. And they should be shared between all the parallel controllers. Based on this logic, we should have around 60 threads, 60 connections, right? Because we have 6 connections per thread, so it's 6 multiplied by 10, so it's around 60, not 371. So why do we have extra 300 connections? And turned out that it's the common JMeter behavior, so it's not related to parallel controller itself. So how the connections are actually managed in the JMeter. So first of all, you can control how they are managed. So in the thread group properties, you have this same user on each iteration checkbox. And by default, it is selected, and in most of tests I have seen in my life, it was also selected. So you are telling JMeter to keep the connection between iterations, and that's fine. So it will kind of run and keep the connection for each new thread group thread iteration in thread group. Like if it is false, if it is unchecked, then it will use this HTTP client reset state on thread group iteration property, and by default it is true. So kind of when it is selected, it will reuse connection. If it is unchecked, then it will create new connection for each thread iteration. That's fine. So it is not like in our case we have it checked, so it should not impact any connection, right? But despite having this checkbox set into true, HTTP client 4 implementation, so HTTP client 4 is default HTTP client which is used by JMeter to establish, manage, reopen connections. So it is using one of its properties, which is available in JMeter properties. It is HTTP client 4 time to leave. So it is using time to leave, which is equal to 60 seconds. So every 60 seconds, it doesn't matter. Are you using parallel controller? Are you not using parallel controller? JMeter, your thread, actually not a thread, HTTP client 4 will reopen the connection. It doesn't matter what type of request are you using. It should be HTTP request, obviously. But yeah, it doesn't matter in which controller, or is it parallel controller or just sequential calls, it will do it. So it was a surprise for me because I thought the JMeter keeps the connection for a longer time. And I checked the commit history, so turned out that this behavior, it was also changed some time ago, just to emulate or mimic browser behavior, because browser is also not I have also checked it manually. So browser is not keeping connection open. If you start interacting with the page, it will change the connection from time to time. So this behavior was done just to be more realistic in terms of in creating the connections. So this 371 requests instead of 22,000, it's more proper value. It's more realistic value. Yeah. So from functional standpoint, it works, right? So I have showed you that it works. It shows requests in parallel. it used 6 connections. It is reusing those connections and answered the question like why it is reopening them still from time to time. But it is only like on the one user test, right? But in except reusing connections, I also mentioned the excessive kind of load generator usage. So it is performance issue, right? So we also want to figure out what is the impact of these changes on the performance of the parallel controller. So in this case, we have like a little bit uh, different scenario. So we have like 4 gigabytes for JMeter heap size. Like so, JMeter will use up to 4 gigs. Then we have 30 JMeter threads. So in this case, do not pay attention to thread group itself. Pay attention just to the structure. So we have no parallel controller. So in this case, it is just it is a thread group. So we have multiple thread groups with simple controllers. Each simple controller will have, I don't remember, but around 10 samples. Then we have original parallel controller, original implementation, and the parallel controller with fix. So in each case, controllers have 10 samples inside it, 10 requests inside it. So we have executed test for 30 JMeter threads, 60-second ramp up, and like 3 minutes duration. You may ask like, oh, 30 threads? Is it a real load? Come on. But let's check the results. So when you're using original parallel controller, even 30 threads, it may be too much to like, it will use too much resources, too much RAM. So you will just, you will be out of memory. That's the results. Like in all these screenshots, first one is no parallel controllers at all. Second one is original parallel controller, and last one is parallel controller with fix. So number of threads, you see that amount of weight in threads, it's significantly, it's huge. Yes, obviously, with parallel controller, even with fix, we use more threads comparing to the case without parallel controllers, just because without parallel controllers, we are not creating extra 6 threads per JMeter thread, right? So that's obvious. That's intended. But the problem with the original one was that it was creating a new thread for each parallel controller child. So the higher, the bigger scenario you have, the higher number of parallel controllers and requests inside them you have, the more threads you will create. So in this case, for 30 threads, it has created like almost 2,000 threads. That's huge. And like almost all of them, they were not doing anything at all. So for connections, during this 3 minutes test, without parallel controllers, we created 80 connections. Again, not 30, because JMeter was reopening them every 1 minute. Original one is 26,000 of connections created, and with fix it's 350. Again, significant decrease of extra SSL negotiation or like HTTPS connection establishment on the server side, because for each connection, your JMeter need to like both JMeter and your end server, they need to spend some time establishing this connection, so it affects all your requests. So in fixed version, we are reusing those. That's the CPU utilization. So yeah, when we are using parallel controllers, in both cases, we are using more CPU just because we are generating more load. But the process load, like actual JMeter GVM process, it is using less CPU comparing to with original fix. Yeah, it's not like it's not so significant improve as for connections, but still, like why should we spend like now we can use this available CPU for generating extra load, not just with not just for struggling with not optimal implementation. Garbage collection activity. So in fixed version, we use less. We're spending we're using less memory, so we spend less resources for garbage collection. That's the amount of CPU garbage collector spends. JMeter throughput and errors. So you may see that when you're using the parallel controller with same amount of JMeter threads, so we are generating like what 3-4 times more requests per second. So that's kind of partially answer question, why do we use more CPU? Actually, we use how much, like 2 times more CPU, but we are generating 3 or 4 times more load with the fix. Without fix, you see, even with 4 gig, like with not huge load, with only 30 threads, we are like at some moment we are start getting errors. Obviously, these errors, they are related to kind of lack of memory, and the response time, they also becomes unstable. So, and also these errors, they might be so there might be different root causes for these errors. First, we are lacking RAM, available memory. Second one, we are out of ports or file descriptors on our load generators. Third one, we are out of ports or file descriptors on the server side, application side, because we opening too much of them. And maybe something else, but that's the 3 common ones. For the response times, it's really clear that with no parallel controller and with parallel controller with fix, response times are similar. Like maybe they are a little bit higher just because we are generating 3 or 4 times higher throughputs, higher loads. But in general, there is no significant difference. But original parallel controller, it has a significant increase of response time. Why? Because for each and every request in parallel controller, we are spending extra time for establishing HTTPS connection. And like later, when we start struggling with memory or connection limits, then we start getting even spikes, like spikes both up and down. And the heap usage, so from this point of view, yeah, like it doesn't look like we have significant improvement in JMeter, like in the heap usage itself, at least from the heap chart. But from the garbage collection activity, we see that we are spending less time on clearing some, unnecessary things. So as you see, these spikes, like spikes down, garbage collection. So it means each spike down, it's garbage collection. So with the original fix, we are doing garbage collection much more often, trying to free up some memory and remove unnecessary requests. So that's the high level overview of results. So now we're going a little bit deeper into what was actually changed, and how I was kind of debugging it. So yeah, as I said, so it is really getting source code, both for JMeter and for parallel controller, both codes. Get the ID, like in my case, IntelliJ idea, and it allows you to set up remote debug. So remote debug, it means that you start JMeter with just extra argument for JVM, and your ID, it is able to, like, you can put breakpoints in your code and it will attach to the running process. So no need to start JMeter from code. You run your JMeter as usual, but it will this remote debug allows you to attach the running JVM and like set breakpoints, go step by step in code, like in normal debugging process. And also, additionally, as we are not only focusing on some functional stuff, we are interested in also some performance impact. We need to have we need to profile our application to see how many connections were created, what is like the CPU usage, garbage collection, threads usage, and so on. So for this, I have used the JProfiler. And after each kind of step or even like small change, I need to run tests just to validate was it right decision or not, what is the impact both on both like from functional perspective and performance perspective, as well as using as usual using the proxy debugger, like proxy debugging tool like Charles proxy, to see like our requests are actually executed in parallel or not, or they are executed sequential. So that's the typical approach for debugging any issue. So it's a profiler first, because using profiler we identified all these connection issues, thread issues, and now we start debugging just to figure out what is the actual root cause. Um, yeah, so initial state, like we mostly talked, like I already talked about it, like some of this. Let's just summarize. And also, I just want to add as much details. Just like even if right now it is not clear, you can check this recording like several times and try to figure out deeper and understand what is going on. So first of all, first point to keep in mind that the implementation is pretty straightforward. So for every parallel controller which exist in your JMeter script, uh, the new concurrent executor will be created. So concurrent executor is actually just an uh, create, like it's a place to create like it's not a place, it's a way to create this extra 6 threads, 6 Java threads to and execute them concurrently in parallel. So that's the main reason to create them. And like for every parallel controller, for some reason, the new concurrent executor was created. So that's why for each parallel controller, we are creating new threads. And because of new threads, we are creating new connection and so on. So there are few implementations there. So they are using one of the implementations where we are able to limit maximum amount of parallel threads. So I'll have some kind of high level overview of dependencies, like what is created after like one by one. So every sampler and controller. So we are get for every sampler, actually for every direct child of parallel controller, we are creating new thread and new connection. So if we have one parallel controller with 20 requests inside it, it will create 20 new threads with 20 connections. And you obviously saw it in the test results with the thousands of connections created during pretty short test. Uh, Let me check. Yeah, so each new, if you have multiple parallel controllers in your scenario, so for each new parallel controller, the new this concurrent executor will be created. But uh, let's say first parallel controller, it will reuse its own executor on the next iteration. But still, kind of connections will be still will be created. Why? We'll figure it out later. So step by step, what's going on? So first of all, we are trying to deal with this idling connection, like thousands or hundreds of connections which are stuck in wait state. Let me move myself so you see a code. Yeah, or hold on, let me. I broke everything. let me move myself here. Yeah, so first of all, in parallel sampler, so when the thread is started, we are creating this concurrent executor. So it is right here. I'm not sure, do you see it fine or not? But probably yes. So we are creating a new thread pool and new executor like every time when we get new parallel controller, right? So we want to share this concurrent executor and all the threads inside it among all the parallel controllers. So again, the idea is to make a parallel controller similar to what browser does. So we have one user, one JMeter thread, and I want this thread to create, extra 6 connections, 6 threads, 6 parallel threads, and I want to keep them for the whole scenario. I want to keep them, and I want these connections to be reused, these connections and threads to be reused by all the parallel controllers. We have 20 parallel controllers in scenario. I want all of them use these 6 threads, not to create new one. So that is done by this change. So generally, we just if we do not have the executor service first, look, it is done pretty like straightforward. We just share it in the variable in scope of JMeter thread. So if executor is not available, we create it and put it into variable in the JMeter variable, obviously. So it will be like available for each thread separately. So each thread, each JMeter thread will have this JMeter, what do you call it, concurrent executor and thread pool separate thread pool for separate JMeter threads. So that's the first thing we kind of improved. So now instead of creating a new thread pool for each new parallel controller, we are going to reuse it. So we can run like some simple tests. We have 2 parallel controllers with like some amount of requests inside it, and that's kind of before fix, that's after fix. So we slightly reduced the amount, like we reduced it for 11 requests, 11 threads in this case. So that is good, but still, if we go to like still connections will be created, new connection will be created. So it is the open question we need to face. Okay, let me myself again. So let's try to understand the actual design. Like that's what I promised you to show you. So on the high level, let's start from these bullet points. So parallel controller, it is designed to work with JMeter thread when it's processing its children. So as I said before, implementation is pretty straightforward, and parallel controller is reusing common JMeter implementations, especially when it comes to execution. So we have, let's say, we have a thread group. We have a JMeter thread. It's a common JMeter thread or user, which is executing everything which is inside the thread group. Then we have a parallel controller. This parallel controller, for each, like by default, originally, each parallel controller creates separate concurrent executor Java thread pool with 6 threads by default, because we are limiting it to 6 threads. This thread pool, it has 6 Java threads, so it is not a JMeter thread. It's just a Java thread, like separate thread which is doing some work. In that Java thread, we have dummy thread group class instance. It's a specific class implemented just in parallel controller, and probably they created it just to I forgot the word. So just to mimic the same, like to create the same behavior as JMeter core expects. So why do you need this? Because generally, JMeter thread parallel, the actual thread and class with implementation, how the scenario should be executed, it inherits the common JMeter thread. And the JMeter thread, it needs thread group. So it is really dummy thread group, which is not doing anything at all. It just required by JMeter design. And inside JMeter Parallel, we have the actual sample or controller which is executed. So might look a little bit overwhelming, right? But generally, from this kind of hierarchy, what do you need to understand is that parallel controller itself, its implementation, it mostly inherits common JMeter thread implementation. And that's the main problem of it. Because we expect parallel controller to work a little bit different from the regular JMeter thread. And like later you will see that the main reason why do we have issues with connections is just because we are relying on JMeter thread, on the core JMeter thread. But on the other hand, it really simplifies the implementation because currently parallel controller, it is able to execute whatever you can put in JMeter because it actually uses the core JMeter thread implementation. So it doesn't care do you place their HTTP request or controller or GSR 223 sampler with some code or listeners, it will execute anything because it's just a regular JMeter thread. So yeah, we create a separate instance of JMeter Parallel. New connection. Okay, so let's talk about the connections. So we have, because we are reusing regular JMeter thread, JMeter thread is reusing JMeter thread, each new instance of JMeter thread parallel is creating new connection. And it actually sounds reasonable in the JMeter ecosystem. Yeah, because when the new JMeter user or thread is created, it needs to have the new connection. And when it ends execution of scenario, it closes the connection, right? So that sounds pretty reasonable, but it is not what we need for parallel controller. So why? it is not good. So we want these small parallel JMeter thread parallels, like these 6 ones. We want them to be reused. We want them to have a little bit different logic comparing to normal JMeter thread. Because let's say we have some e-commerce end-to-end scenario with 35 parallel controllers in scenario, right? So we want these 6 threads to be reused among all 35 controllers. But originally it is creating new threads, parallel threads for every controller. So it's generating really huge amount of connections. And how the connection is managed? Because yeah, we are creating, yeah, we are reusing JMeter thread, but why the connection is closed? Because normally in JMeter thread, till the end, if we are reusing connections, if we have this checkbox, same user in each iteration, connections are not closed. Yeah, it is reopening it once in 1 minute, right? But it is not closing them at the end of iteration. But in our case, each parallel controller thread, after it ends this sample execution, even one request, it closes the connection because it thinks that, oh, my scenario is completed. Like, and generally, it is not managed by parallel controller. So it, first of all, it relies on JMeter core, and in JMeter core, connection is managed on the sample level. So it is using this HTTP HC4 impl class. Like HTTP client for each thread, HTTP client is created, and it is stored in thread local instance. It's some details, but just I need to keep this information. So it means that generally each thread, they have separate HTTP clients, right? But so after our previous fix, after this fix, when we start reusing thread executor, like this concurrent thread pool and these concurrent threads, we have constant 6 threads, right? But for some reason, and like the HTTP client itself, it should be the same, because new threads are not created. But for some reason, something is forcing thread to close the connection. And it is done actually in the JMeter thread. And why, we'll figure it out a little bit later. Probably maybe in this one. Yeah, in this one. So in the core JMeter thread class, which is actually the main class which is responsible for all your scenario processing, we have run method. And parallel JMeter thread is reusing this run method. So at the end, when the scenario execution is done, and in our case, scenario execution is done when even one request in parallel controller is executed, right? So we have 2 lines of code. It's remove contacts from JMeter context service, which is removing thread local entry, and thread local entry or instance, that's what I mentioned here. So it's actually the context of your thread, like with all the variables, properties, and all other stuff. So it is clearing it at the end. So first of all, and also another one is called like if we comment the first line and run the test, we'll see that connection, they are not reused, because connection HTTP client is reused, but something is forcing connection to be closed. And in this case, there is another line called like test tree traverse shut, which is calling thread listener thread finished, which causes call of HTTP client implementation thread finished, and this thread finished actually is forcing to close local connection of current thread. So yeah, it sounds a little bit hard to understand from the first time, but like it was not. It was like several days of debugging and trying to go like JMeter itself. It's pretty complex monster. Not a monster, but it's a complex Java application with a lot of dependencies, right? So you need to go through really long kind of dependencies to figure out what is exactly causing the something. In our case, closing the connection. So in our case, this line of code in JMeter thread run like called another method, and then it called HTTP client implementation thread finished. So like let's try to comment, and this is a actual implementation of JMeter thread. So as a first really simple solution, I just tried to really comment these lines. So let's see, will it help or not? So we comment thread finished and remove context. So first, this one should not now remove thread local with the HTTP client implementation, and this one should not close the connections. Okay, so we run the test, and so here it's the first iteration. So on first iteration, only 6 connections are, and in this case we have like around 20 or even more, how many? Yeah, 19 requests executed, and only 6 connections were opened. So that's good. So we are not opening extra new connections. So we made a small step towards our goal. But still, after all new iterations, we still start getting more connections, unfortunately. So commenting this, so like there is something else we need to kind of figure out, because it partially helped. So we are one step closer to solution, but it is not yet done. And the requests, they are executed in parallel. So after each change, we need to control that at least we are not breaking it from the functional standpoint, from the functional perspective. And also one more problem, that after we commented those two lines, we broke amount of threads, like amount of threads visualization in the UI. So now it is reporting like each new parallel thread is reported as a separate actual thread in JMeter, but it is not expected behavior. Okay, so we commented something. We reused the HTTP client and the connection on the first thread group iteration, but on the new thread group iteration, it is still new. So when we dive a little bit deeper, turned out that JMeter thread parallel, which is inheriting JMeter thread, it is passing is same user on next iteration equal false. So that's that checkbox that we see in UI in thread group. So when the parallel JMeter thread parallel is created, it is actually telling JMeter to reset connection on each new iteration. That's why even if we are using HTTP client and connection on the first iteration, then it is like breaking on the next and the following ones. So instead of calling this one, so it is calling like this super task monitor and notifier. So it is calling the super class constructor. So it is the default implementation, this one. So instead of having false, doing this one, we need to use like actually, honestly, it is not. It is using a constructor with only 3 parameters, with the test monitor and notifier. But it is not like this change, like ability to pass each same user on next iteration. It was added later. So the current implementation of parallel controller, it was based on JMeter core like version 3.1, so pretty old one. And in that core, there was no way to pass each same user on next iteration. So my goal, like I tried to pass, instead of doing super task monitor notifier, I wanted to pass task monitor node and true. Like to start using this new what do you call it? Start using this new constructor. But unfortunately, it starts like throwing exceptions like that. I cannot use this type of, like, there is no constructor with 4 parameters. There is only one with 3. And the reason was that in parallel controller 0.11, they relied on JMeter 3.1 version source. But like we need just to change it to 5.5 in POM XML, and then it is fixed. But then we got another problem, that in 5.5 the core JMeter core source code was changed. There was they added one more abstract method, and like our current dummy thread group, it doesn't have implementation of abstract method add new thread in abstract thread group. So we need to implement it. It's just a dummy implementation without any logic, because we are not using actual thread groups in this case. And now we are able to call, like when we are inheriting JMeter thread in JMeter thread parallel, we are able to call the new constructor and pass, like, is the same user on new iteration or not, instead of having false by default. So that's what we need. So we passed it, and now instead of like we have so we probably executed it for some time. So we have, instead of having 52 connection in the previous test, now we have only 12. I don't remember why 12. Probably it had like it was 2 iterations, like 2 minutes, I mean. But generally we decreased amount of connections in this case. Like it is the actual fix that helps us, but still we have the problem with amount of threads displayed on UI. So after we comment thread finished, which was closing the connection, in this thread finished code, there was a line like JMeter context service decrease number of threads. This line was actually responsible for decreasing amount of threads on UI. So we kind of disabled this logic, so we need to enable it back. So we uncomment thread finished here. We uncomment this one, and actually we will uncomment this one too. And I just add like this small change to JMeter core. So this thread finished is a part of JMeter thread class, which is part of JMeter core. And we need to, I just added one if. So this code was here, these 2 lines. So I am executing these lines only for everything except JMeter thread parallel. So this, if like this class, instance of this class is calling JMeter thread finished, it will not go and like finish this thread. Like it will not close the connection. It will not force closing the connection. So that's the single change we made in JMeter core. And like generally it is not affecting anything else except parallel controller threads. Why? Because first of all, it will be done only at the end, at the very end of thread execution, so at the end of test. And it will check, like, and if it's not JMeter thread parallel instance, it will execute it as usual. So no other changes in JMeter core, so don't be scared about changes in JMeter core. And also, what else we did? Yeah, and I also added similar if to remove context. But turned out later that in reality, this run method and removing context, it is not affecting the connection itself, because after like further investigation, turned out that the actual JMeter context, the actual HTTP client, it is stored in inheritable thread local. So it's a totally separate object, and it is not cleared by remove context. So we kind of reverted all the changes back. So we removed this if, and but we keep if in the thread finished. So we keep only one if condition for JMeter thread in core. That's it. So that was like kind of the final version of scripts. And generally, after we run the test, right now we have 12 connections. We have because probably it was one like more than 1 minute test. Then we have fixed amount of threads here. We do not have 80, and we have all this performance improvement that I showed you before. So to sum up, like the final change or a final set of changes, and why do we need them? So first change, it's in parallel controller. Like we have 2 jar files, right? So in parallel controller jar file, first the change is in JMeter thread parallel. So we changed our superclass to use to pass what do you call it? To pass is same user on each iteration to true, not to reset connection on new iterations in parallel threads. That's the first change. Only one change in this class. Second one is parallel sampler. In parallel sampler, it was the first change we did. The goal is to reuse concurrent thread executors and thread pools, and like just start reusing parallel threads. Share them between parallel controllers. So that's second change. Like it's a second change in the different file, but still it's related to parallel controller jar. Another parallel controller change is to create this new dummy add new thread abstract method implementation, just because it is required after we changed the parallel controller dependencies from JMeter 3.1 to JMeter 5.5. So it is not actually used anywhere and it is not affecting anything. And the last change, it is unfortunately in JMeter core. So we need to use it just because parallel controller is deeply relying on the JMeter core, JMeter thread implementation. We need to modify a little bit logic of thread finished method, just not to force HTTP client to stop connections when thread thinks that it is finished. Yeah, unfortunately, like if the JMeter thread, if like this method would be public, we would be easily able to override it, and actually we would not need to change the JMeter core. But most of methods in JMeter threads, they are private, so it means that you cannot override them in JMeter parallel thread. So we needed to add this small change. But I believe it's not a big deal comparing to, yeah, it's not, probably it's not, it is stopping me from, creating a pull request to parallel controller, because we also changed the JMeter core, and probably they would not like to add specific dependency on some plugin in JMeter core. And also another problem here is that even if I would create a pull request, I'm not sure that it will be actually reviewed, because bunch of pull requests, they are like hanging there like for half a year. So I'll just keep it like as a kind of my local changes, and like you also can change it and use these jar files, but it will not be available in parallel controller, like from plugin manager, let's say, at least so far. So yeah, we have only four changes in code. Yeah, it's really, it's only high level overview, because there were a lot of deep in research investigation how it works, what are the root causes, and like how we can easily kind of fix it without changing. Like I don't say that it's the perfect solution, but I don't want to spend time, and probably I don't want to redesign parallel controller and create something new, right? My goal is actually to solve my issue with excessive resource consumption, connection creation, and actually not realistic behavior. So I was able to achieve this by these three, like, I would say, relatively simple changes. Yeah, so you can also feel free to, if you want to change something in parallel control or add something, feel free to get the source code and just apply these changes. It will take like half an hour for you, probably. So if you want to build your own parallel controller, let's say you want to change something or modify the logic, or you want to get the core jar file for newer JMeter, then you can like there are some steps. Like I'm not providing this detailed manual because I'm not sure if anybody will do this. But generally, you need to get a code of JMeter, source code, which you are which you want to use or you are currently using. Then you need to apply a change from the previous slide to Java thread file. So the only change you need to add is this one to JMeter core. And then you need to build JMeter from source. So you can use like I have used this Gradle kind of configuration or command. So in JMeter they already have this Gradle command like create distribution. So you use it, you can use similar configuration, just run it, and you will get like fully built JMeter binaries. So your goal will be just to use Apache JMeter core jar file from this new build. That's it. Yeah, probably again, you may face any like new unexpected issues just because JMeter core was changed in new version or something else is not working, or even parallel controller might stop working in new version because of any reason. So be ready if you want to use it with newer JMeter. So like with 5.5, I have already tested it, but with newer version, it might take more time, and more effort for you to make things working. But in general, nothing stops you if you have desire. One known bug, which like I am not actually fixing and I'm not too much concerned about. So I faced it. Let's say if you're using this parallel controller, so we are actually creating threads, and they are uh, they are kept static, so they are not closed just because we removed thread like this thread finished part, not thread finished. What do you call it? Yeah, thread finished with this thread listener traverser shot, which actually closed the connection and stopped the thread. So they are living, they are alive for JMeter instance. So while JMeter is up and running, these connections, these threads will remain open, will remain running. So let's say if you open JMeter, open some scenario, and go to HTTP request defaults to modify uh, proxy settings. Let's say you want to use a proxy debugging tool, and then you started a test. These threads were created with these settings with proxy, like localhost 8888. Then you go to request default and remove this setting. All parallel threads, they will not apply this change. So you will need to kind of reopen JMeter. Like one workaround, and a pretty straightforward workaround, is just to reopen JMeter, and that's it. So it will remove. So you can treat these parallel threads as a properties, kind of, because when you create some property in JMeter, it will live in JMeter while JMeter is running. So it's kind of global thing. In our case, parallel threads, they are not global. They are on the thread level, but still they exist and live. So just keep it in mind. Yeah, finally, I finished. Like I'm done. General like with main kind of uh information I wanted to share with you. So if you have any questions, yeah, first of all, thank you for listening, because especially this last part, it might be pretty overwhelming, and but it's good to have it at least somewhere documented. Uh, if you want to run these tests, so I will share this archive, so feel free to use it. If you will face any issues, maybe I missed something, or you have any other ideas, feel free to ping me, like in LinkedIn or in Telegram or in Perforator Club. Let's, if it's really something that we can fix, and we need to fix, let's try to figure it out. I believe I saw a message that yeah, if you have any questions, feel free to ask. I saw a message from Vlad that yeah, let's go through the script. I believe it's the script for what? Yeah, for creating this parent sample. Just with some quick comments how it is working. Yeah, so it was a long time ago. Okay, finally. We are here. So let's start with this code, right? So as I said before, main goal of this code is to like first of all dynamically let's go like line by line, right? So we are checking if we have the variable timestamp before, like which should like we're checking if the timestamp exists, because if it doesn't exist, it is set to 0. So in this case, yeah. So we have, if we do not, if we see that timestamp is 0, sorry, if timestamp is not set, it will be this part. So we actually on the first iteration, on the first this technical calculate transaction processing time, we check if timestamp is more than 0, but in reality it will be 0. And we start like if we have timestamp before equal to 0, or there is no timestamp before. So on first iteration, honestly, it will be no timestamp before because it wasn't created anywhere yet. So what we are doing, we are creating timestamp before and putting new like actual timestamp, just this Unix timestamp into this variable. And by default, we assume that transaction is successful right now. So we are on the first, in the first transaction controller, in the first this GSR sampler, we are actually creating timestamp before and is transaction successful true. Then we start executing, so we got initial timestamp. We start executing all this stuff, so it doesn't matter how much request or logic do we have here. We are JMeter is executing it until it comes to the same implementation, same module controller, same code. But in this case, instead of going inside this else if, we are checking that now we have timestamp before and it is timestamp, so it's some number. So we are going inside an if. So in this if, what we are doing, we are creating timestamp before. It will be actually value of timestamp, like timestamp from this point, right? That we created before executing all these requests. We have the timestamp after, it's the actual current timestamp. We calculate the duration, it's a difference between timestamp after minus timestamp before. Then we need to execute these 3 commands. It's kind of a little bit of magic. What is like it is the way how to get sample listeners. So to like our end goal is to create a new sample result. Sample result, it's actually JMeter class, like type of object, which is storing result of sample execution. So everything you see in view results tree, it is sample results because it contain what was the request, what was the response, headers, response times, and so on. So our goal is to create this sample result, kind of create a new result of user action or user action. And if we just create sample result, it will not be displayed anywhere. So these 3 lines is to get, like, first one, we are getting current thread. Second line is to get, what do you call it? Listeners in scope of current sample. So this sample is actually like in test fragment. So we are going to have, these listeners will be applied to this sampler. So they will be in context of this sampler. So this line 10 will give us these 4 listeners. Then in line 11, so actually line 10 is a little bit of magic, because this JMeter thread pack, I found it only after debugging JMeter, seeing how it works under the hood. So you will not be able to find it anywhere, like in documentation and so on, because you are not expected to get listeners from your GSRs. Then in line 11, we create a new sample result. So it's an instance of sample result class, and pass 2 parameters. The parameters. First one is the timestamp when when it was created. It's the current timestamp, and the duration. So it needs, like, every sample result. It need to have duration, response time, and also when it appeared, because like even in Grafana we want to see this response time at some moment of time, right? So we pass these 2 parameters here. Then we interact with sample result. We're setting a label. Again, a little bit of magic. So we are referring to the same JMeter thread pack controllers, and get second one name. Why second one? Because if you're having same same structure, and I hope it is pretty straightforward and easy to kind of follow. The second controller in this controller list, it will be actual parent simple controller or transaction controller, or any controller. So we get in its name. It's also kind of hack, because there is no, there is no get controllers. So there is no getter for getting controller. So it's more like, again, dirty workaround, and I'm happy that I was able to get it, because googling and checking Stack Overflow, like everybody just tell that it's not possible to get controllers properly. So we set the sample label, set that it is successful. By default it is successful, but it may be, and after setting that it is successful, we are calling thread get notifier, notify listeners, and passing, like, creating new sample event just because it needs to be passed, and passing this sample result that we created right now, and passing this sample to sample listeners in our scope. So generally, long story short, we get the timestamp before, timestamp after, calculate difference, create a sample result, create an actual kind of user action result with duration and status and name, and send it to listeners. And after that, we reset timestamp before. So at the end of this if, we are ready, like, next user action, let's say open speaker page. The first calculate transaction processing time will go not in this if, but in else if, just because timestamp before equals to 0. It is resetted. That's it. So it will just, the same code will continuously work properly. All you need to do is just to keep this structure properly. So structure properly, it means that you need to have calculate transaction processing time at the beginning. Like, you need to have 2 calculate transaction processing times. One before request, one after request. That's it. Yeah, so that's the first one. Then we need to use simple controllers. I believe it's clear. Transaction controllers and this listener. So we like in the actual, what do you call it? In the actual first calculate transaction processing time, we are assuming that transaction is successful. We are setting it to true. But if at least one request will fail during execution, we need to fail the user action too. So we are creating a GSR223 listener. We need to get class. Like we are checking if it's sample result. Why do we need to check if it's sample result? Because not all types of elements has this API like to check prev is successful, for example. So just not to break anything. Because like if you have some think times like action, flow control actions, this code will just break. So we are checking, we are applying it only for HTTP requests. Why it is synchronized? It is synchronized because generally a lot of stuff is executed in parallel, and this listener will be unstable because of this parallel execution. So listener is executed like synchronously. It just relies to create some synchronized implementation. We need to refer some object. I just used the common variable which is available for every JMeter thread when JMeter test is executed. So just we how you need to treat this code, that it will not be executed in parallel. So despite having requests in parallel controllers, yeah, they will be executed in parallel, request itself. But this listener and checking is it successful or not, it will be executed sequentially. Yeah, so it is probably a kind of extra possible bottleneck, but that's kind of what I end up with. And here we just checking is the transaction successful, and like we're actually putting into is transaction successful result of this condition. So if previous request is failed, like one of the parallel controller requests is failed, it will fail this condition and we will put false in is transaction successful. And in general, it will be like if at least one request will be failed, the whole transaction will be failed. So like I have tested it, it works properly. Like if you have any ideas, again, feel free to share it, how to make it more efficient. And that's it. So that's the code. It looks pretty straightforward, but if we just omit all the these experiments done and all different approaches tried, yeah. So feel free to use. Oh, I see a few more messages. Yes, thanks for useful information presentation. It's interesting to know if we're using BlazeMeter as load generator, could we change these core jar files in BlazeMeter? So when I was testing HTTP2, so I needed to, and like we also made the changes to HTTP plugin. So you are using what do you call it? This Taurus. You have Taurus scripts. Like you can avoid using Taurus scripts in BlazeMeter, but if you have some complex preparation steps, you need to use Taurus scripts, and yeah, you are able to yeah, just ping me in Perforator Club. I can show you some examples of like how we did it. So in general idea is like each JMeter load generator in BlazeMeter, it is using separate uh, it is using like separate EC2 instances, right? And they are kind of bootstrapping this EC2 instance. They are installing JMeter, all this stuff. And before running test, you can actually modify uh, everything in JMeter bin, in JMeter lib directories. So your goal will be actually to, before test starts, to replace JMeter core and JMeter plugin versions. Because like initially we needed to do the same, but we replaced only plugin, but we did it manually. So we needed to talk to support how to do this. So they spent again a lot of time figuring out is it possible or not. Not a single conversation. So it was pretty, for some reason it was something new for them. So no, I don't know, maybe nobody requested to do same action. So it is possible. Yeah. Another question: if started changing code and the only problem with create parent sample option of parallel controller was hiding child samples, won't it be easier to add another option, don't hide child sample and do not GSR? Yeah, but initially I didn't want to change the functional kind of all these changes we did to JMeter core and parallel controller itself. They were not affecting the actual functional perspective of the controller. So, you know, if you change something in code, you need to properly test it. And like, I wasn't sure that I want to spend like these extra efforts into like changing functional behavior and check that it's working fine and maybe later face some corner cases. That's why initially, so like I figured out this approach with creating GSRs before I started changing parallel controller. But even right now, after I changed the parallel controller and the core, JMeter core, I don't want to go and change the functional behavior of parallel controller, because yeah, I am just not sure, and that I want to spend time testing it, because it really takes a lot of time to find all the possible bottlenecks, especially when it comes to some parallel request handling. Yep, so looks like no questions. Then again, thanks for attention. Uh, if you will, like, if you start using this all these changes in future, uh, feel free to, and like when you start using this change and you feel that, oh man, there is an issue, and like I cannot use it properly for some reason for your specific case. Maybe you just didn't get the idea how to use it, and let me describe once again. Or we really need to fix something. Or maybe like I haven't yet faced some corner cases. So let me know during our Peripheral Club, subscribe and all this stuff. Have a good day, evening, and see you on the next events. Bye bye.